Hello, hello, and welcome back. We are now getting into chapter one. So, in the prologue, we talked a little bit about the history of psychology. And when we started talking about that, we started with the original psychologist who founded psychology and coined the term psychology. His name was Wilhelm Wundt. And one of the things that was most interesting about him is that he talked about how psychology needed to be a science. So normally we would go through this in 3 parts, but I think I will try and split it up into 2 just to make it easier on us. The 3 sort of portions of this chapter are the need for psychological science, research strategies, how psychologists ask and answer questions, and statistical reasoning in everyday life. Now, I know that this probably scares people and they think that we're going to have to do math problems and statistics and things like that. And the answer is no, we're not. So don't worry. But I do want to teach you about what we do, how we pool data and things like that, and use statistics in psychology. But no, don't worry, you won't have to do math. So what I'll do for this chapter is I will go over the need for psychological science today, and then I'll go through 2 of the 3 research strategies. And then when we get to the actual experiments, that's when I'll start that and statistical reasoning as the second part of this lecture. So again, with Wilhelm Wundt, he said that the science of mental life, remember he said it needed to have carefully measured observations and we need to do experiments. And the reason for that is because it needs to be scientific. We can't just go around guessing and hoping that our intuition leads us in the right direction. Now, I know a lot of people like to rely on their intuition and rely on their common sense, but the problem is that human beings, as a general flaw in our programming, is that these things are not reliable. And I will give you some examples of this. But the 3 phenomena that I'm going to talk about in this chapter that illustrate the fact that we can't rely on our intuition by nature is faulty, as is potentially our common sense. 3 things that illustrate this are called the hindsight bias, judgmental overconfidence, and the tendency to perceive patterns in random events. So we'll talk about these things, and as we will see, because of these things in nature, in the world, we can't just rely on our intuition. I'm going to give you a story really quick before we get into this, okay? Let's just say that you're walking down the street, driving down the street in downtown LA, scootering, getting an Uber, whatever it is. You're going down the street in downtown LA. You see this person walking down the street. This person is wearing clothes that look pretty dirty and worn out, look pretty holy in the sense that they're full of holes, not that they're religious, and maybe comfy, but definitely look like they've seen better days. And the person seems to be walking and talking to themselves. They're not on the phone. They seem to be talking. What's your first instinct? In this case, a lot of times when I ask this in class, the first instinct is this person is homeless. Maybe they're on drugs, probably a mental diagnosis, a psychological diagnosis like schizophrenia, which causes people, we'll talk about that in the last chapter, causes people to talk to themselves or hearing voices that aren't really there. And this probably would be correct because downtown LA is, I think, the biggest per capita footage of homeless people in the US. I don't know if I have that completely right, but it's pretty close, or it was at least at one point recently. So, maybe 8, 9 times out of 10, you'd probably be right if in that guess, using your intuition, using common sense, not really knowing anything about the person or about the situation, just from what you saw. The problem is, what about the times that you're not correct, right? So the story goes that this person lives in downtown LA, and it's a Tuesday, and Tuesday is this person's day off. And when he's off, he likes to wear his old clothes, old sweats and t-shirt from college. No need really to get dressed because it's his day off. And then he realizes, oh man, I'm out of a few things. This guy lives, a couple blocks in one of those nice apartments, but a couple blocks from Ralph's. And he doesn't really want to drive to Ralph's because he's got a really nice spot. And it's a couple blocks away. So why would you do all of that just to go and park in the Ralph's parking lot and then come back? So he decides, I just need some milk, some eggs, sniffs his armpits, some deodorant, right? And so I'm just going to go and walk. And he leaves his house not thinking about it. And he is about half a block away, or half a block down from his apartment, when he realizes he left his cell phone with his list of things to buy at home. Now, at this point, he's already almost halfway to Ralph's, so he could go back and get his phone, but he wants to get back quickly, right? He wants to enjoy his day off. So he decides, all right, I'm just going out. I don't care what I look like because I don't care if people see me. It's my day off. So he's wearing his comfortable clothes. Nice paying job, too. And on his way, he is trying to now remember what it was he was going to get at Ralph's. So as he's walking down the street, about the time that you see him walking by, while you're scootering, riding, walking, whatever, you see a person that is wearing clothes that could be mistaken for a homeless person's clothes because they're comfortable to him, built-in air conditioning with the holes. It's hot outside. And he's saying to himself over and over so he can remember his list: milk, eggs, butter, deodorant, milk, eggs, butter, deodorant, right? But at the time that you catch him, it looks like he's potentially homeless and crazy. So in this case, intuition and common sense is not going to be the right answer. How could we mitigate this? How would you be able to know that your guesses are correct or not? You can give him a survey by going up and asking a question. Sorry, sir, I know that you're busy or whatever. I was just wondering, are you homeless? Do you need something? Can I help you? And the person would say, no, I'm just trying to get to Ralph's. It's my day off. I'm wearing my comfy clothes. And now I just want to get to Ralph's and get my, oh, great. Now you made me forget what I was going to say. Right? So maybe he remembers deodorant, hopefully. But in that case, your intuition and common sense would not be appropriate in this manner. And we can't, in the field of psychology, just rely on guesses like that to come up with actual theories for why people do the things that they do. So let's look at these three phenomena. Hindsight bias asks the question, did we know it all along? Because hindsight bias is also known as the I knew it all along phenomenon. The definition of the hindsight bias is the tendency to believe, after we've already learned the outcome, that we could have predicted it, that we knew it all along. So watching the Super Bowl a couple years ago, and the Falcons are up 28-3 in the third quarter, and everybody says that the Patriots are finally done, right? I was hoping that was the case. It was not. Brady came back. The Falcons fell apart and tried to play keep away instead of executing. And that 28-3 lead turned into overtime where they lost. A lot of people said, I knew it was going to happen. I knew it all along. At 28-3, you did not know that was going to happen. Maybe true Patriot fans were really hoping for it, but to say that you could have predicted it, right? That's kind of a falsehood, right? So if you look at the picture on the right, when there was a movie that came out a few years ago with Mark Wahlberg called Deepwater Horizon. A lot of you probably saw it. I don't know if you knew this, but it was based on a true story. They were drilling this Deepwater Horizon. That was the code name for this oil rig off the Gulf Coast in 2010, oil industry employees, which have been known to be a little money hungry and greedy, decided that they should cut a few corners, save a little bit of money. Obviously, they weren't intending to harm the environment, or the reputation of the company, but they thought, if we could save a little bit of money here and there, we can get the thing built and put more money in our pockets. So they ignored a few warning signs, and it wasn't until the thing literally blew up. As you see, it literally caught fire and caused a resulting oil spill in the Gulf of Mexico. The second one, by the way, in the last 30 years. It wasn't after the actual thing blew up in their face that they had the benefit of what we call 20/20 hindsight, that the foolishness of those judgments and trying to cut corners on something as harmful to the environment as an oil rig in the Gulf of Mexico, they didn't realize it until it happened. So we say that hindsight is 20/20. What does that mean? Well, 20/20 vision means perfect vision. And if you already know the outcome, it's easy for us to say, oh, of course I knew it all along. Of course I could have predicted it. So the hindsight bias says we knew what the answer was, even though we didn't really, right? When you already know the answer, you can say you would have predicted it with 100% accuracy. Hindsight is 20/20 vision. But we know that that's not true. If these people could have predicted it, they wouldn't have ignored the warning signs. They wouldn't have tried to save some money in the first place on something as sensitive as an oil pipeline that could be really disastrous for the environment. But people that are interested in making money on oil don't really care about the environment so much, as we've seen. Intuition and common sense. We just talked about the hindsight bias. Once you've seen the answer to something, it's probably easy to say that you could have predicted it. Here, the idea of overconfidence means that people tend to think that they know more than they do. This occurs in both academic and social behavior. So academically, we look on the left where you see three words that are jumbled. We call these anagrams. And these anagrams are words that they make a word, but you have to unscramble the letters. So seeing the answers here, you already have them. And so the question on the left says, about how many seconds do you think it would take you to unscramble each one? Well, knowing that the answer is already there, you have the benefit of what we just talked about, the hindsight bias. But it also gives you more confidence in your behavior than you probably should. So some people, when I ask this in class, say about 5 seconds, 10 seconds, maybe 15 seconds. Well, I would say that for the first letter or the first word, first anagram, water, it's something we drink every day, we deal with. It's a word we use on a daily basis. So I would even say, yeah, in that case, water, I would probably have gotten that pretty quickly. But entry, I wouldn't think would probably be as much. And the word barge, we never use the word barge on a regular basis. Barge into a meeting by breaking down the door, or a barge meaning a large vessel on the ocean. That's a word that, is not used very often. And so we probably overestimate how fast we can do this, especially because we've already seen the answer. This occurs in both academic and social behavior. In academic settings, we use the fallacy of the cram. Cramming for exams. I'm actually going to cover this more in chapter 8 on memory, but I'll give you a little taste right here. People who cram for exams, meaning that they only study and pull an all-nighter the night before the exam is up, those people, tend to not do as well as they think they did. And there are two reasons for this. When you cram and you don't sleep, by the way, consolidating information, as we'll talk about in chapter 8, happens while you sleep. That's where short-term memory is converted into long-term memory. And so you're not able to do that. And when you're cramming, you're actually cramming it all into your short-term memory, which is not where you recall from. So you're just hoping that you have enough registered in your temporary memory, what we call short-term or working memory, to be able to keep it. Therefore, when people pull an all-nighter, it's not in your long-term memory, and if you don't sleep, it's not converting to your long-term memory. This is why people think that they were going to kick butt on this test, and then when they get the first exam answers back, they're like, wait, why didn't I do as well as I thought? So that's your overconfidence. Again, we can't rely on things like this. We have the Carnegie unit that I specified in the syllabus that talked about 6 hours for every 3 hours in class, right? 2 hours for every hour spent in class for studying. In social behavior, since we're not going to be going over the social psychology chapter, there's something we call the fundamental attribution error. And what that is that when we are in a social setting like Starbucks, and let's say you see somebody, and this is more often it will happen to somebody you've never met before than somebody you actually know. We tend to attribute their behavior to some sort of long-term personality trait and not to the situation itself. So what that means is, let's just say that you're standing in Starbucks, you're about fifth in line, waiting for your latte or to order it, and the person in the front ordered a drink and they just picked it up, and their name was spelled wrong on the cup, which apparently for Starbucks is pretty standard, and that they got the drink wrong. So the person goes ballistic, throws the cup against the wall, coffee splatters everywhere, they start yelling at their barista. What's your first thought? This person's crazy, they're a lunatic, they're an a-hole, they're a jerk, whatever it is, right? The problem is we don't know anything about them. It could be that morning their dog ran away, somebody in the family died, they lost their job, all of the above. And all they wanted was just a latte. I just want a latte to calm me down. And when that didn't go right, that seemed to be the thing that made them go ballistic. But we tend to say that the person who cuts us off in traffic, the person who yells at their barista, is an a-hole or a jerk, which extends to everyday life, as opposed to just having a bad day. So this overconfidence we have, right, is part of this reason our intuition and our common sense can't be trusted to make theories based on this. The last thing we're going to talk about is patterns that try to make sense of people's worlds. If we perceive order in random events, even in random unrelated data, the slide says, people often find order because random sequences don't always look random, right? Hot streaks, luck, superstition, all of that stuff is not going to fly when you're making theories about why people do what they do. People tend to trust their intuition more than they should because they don't realize that intuitive thinking is actually flawed, right? Looking at the example on the right, there was a German octopus named Paul, the Oracle of Oberhausen. And in this in this tank, there were 2 boxes of food in Paul's tank. One on the left had the German flag. The one on the right had the Spanish flag from Spain. And Germany and Spain were playing each other in the World Cup. So they wanted to see if we have a psychic octopus. This psychic octopus was given the 2 food boxes, and whichever one Paul chose was going to be the winner of the match, they said. Paul chose the German flag and ate the food from the German flag box. And guess what happened? Boom, he correctly predicted it. Of course, he had a 50% chance. It's like heads or tails, right? So Paul predicted that Germany would win because he went into the box with the German flag. So the question I ask you is this random or is it remarkable? The answer is it's random. He had an equal chance of going into either box and either team could have won. But we tend to see patterns in things and think that they're signs from the universe or that our luck is on our side or things like that. Jim Carrey did a movie called The Number 23 where there was a bunch of things that added up to the number 23 and it caused this whole conspiracy theory, and he kind of went crazy. And if you've seen the movie, you know what I'm talking about. If not, hey, when this summer session is over, go watch the movie, or even if it's not over, when you have downtime. But the point is that all of these things, all of this data, all of these patterns are in fact random, but people look for ways for them to fit together like a puzzle. I'm going to give you another example. Before I got the job at ELAC, I had made it to the final round at Pasadena City College in 2013. It was my first ever community college interview. Now, the interview was for the job number, because they have to assign a job number to every position. The job number was 415. Okay, job number 415, random. What does that have to do with anything? Well, just wait. The date of the interview was the first interview was April 15th. So job number 415 on 415. Okay, whoop, we got a pattern there. What else is 415? Well, it's tax day, but we're not worrying about that because obviously if I got the job, I'd be paying taxes, but I'm not even going to consider that. 415 is also Jackie Robinson Day. It's the first day that Jackie Robinson played baseball for the Dodgers when they were in Brooklyn, and broke the color barrier. He was the first Black or African-American, right, to play baseball in an all-white sport at the time, which broke the color barrier. Amazing. What does that have to do with Pasadena City College, though? I'm glad you asked. Jackie Robinson, before he lettered in 4 sports at UCLA, went to, you guessed it, Pasadena City College. So here I am, and I remember talking to my mother-in-law that day on the phone before my interview, and I said, isn't this interesting? It's job number 415 on 415 on Jackie Robinson Day, and Jackie Robinson went to Pasadena City College. And I even think that the bus number was 415 going to and from. I didn't take the bus, I drove, but I think there was even a bus that was going from LA to Pasadena City College, and it was 415. I could be wrong on that last one, but either way, signs from God or signs from the universe or signs from whatever, right? People are trying to make patterns out of it. Now, I will tell you on that day that I did kick butt. And I, like I said, I got more interviews and I made it to the final interview, but I did not get the job. My mother-in-law was convinced that with all these 415s and Jackie Robinson Day, that there was a pattern and it meant that I was going to get the job. But if you think about it, there was at least 10 people that interviewed that day for that job. And all of them interviewed on 415 for job number 415. And it was, if maybe they thought about it being tax day or Jackie Robinson Day too. So all of these things, even though it seems to make sense in the pattern, 415 on 415 with 415 and blah, 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 it was the same for everybody. So again, I say random or remarkable, it's random. We can't just use our intuition and say, oh, these numbers fit together, it's perfect. Numerology, right? Sorry, I'm going to have to stop you there, but as a true scientist, this is what gets people into trouble, thinking that their intuition or common sense would lead them in the right direction. This octopus has no psychic abilities whatsoever, sorry to disappoint you, and just because I went for 415 on 415 doesn't mean I was going to get the job. I didn't get the job. It was a little heartbreaking at first, but now I'm here at ELAC and I'm exactly where I want to be. I feel like I won. So why is intuition overrated? Why are errors made? Because people don't realize that our thinking like this is flawed. Hindsight bias, overconfidence, our tendency to perceive patterns in random events, it leads us to overestimate our intuition. It leads us to think that we rely more on common sense than we do, or we should. The way to really help us to sift reality from illusion, knowing what's real and what's not, what's random and what's really a pattern, is this scientific inquiry. Science can show us what's real and what's not. We can separate people into groups of with and without, this and that. Control group, experimental group, as I'll talk about. So we'll get into that. We can see what's real and what's just sort of illusion. But before we get into this, we have to talk about the type of scientific attitude. There are 3 things that make up the scientific attitude. And guess what? At least one of them is why you're here, whether you're a psychology major, or whether you're taking this class because it was either a little more interesting and a little less boring than others, or you realize I may not want to make a career in this, but I am really interested in psychology. And in that sense, you are curious. So your curiosity for psychology is what brought you here. The other two are called skepticism and humility. So let's take a look at these and see what they're all about. So curiosity includes a passion to explore and understand the world without misleading or being misled. Basically, in a world of misrepresentation and quote unquote fake news, we want to know what's real and what's not. Part of this idea of intuition and common sense is that we just look at the headline of an article and we automatically believe that it's true. And what do? Whether it's fear-based, whether it's just getting information out that we want, we repost, we retweet, we copy and paste into or forward an email. If we don't know that things are happening, right, we are ending up being part of the problem. If you're there telling people that wearing a mask you shouldn't have to wear a mask because it doesn't prevent germs from spreading, and it's we need healthy bacteria. That's the argument that I've heard from a lot of people in Orange County and across the country. Well, if you're not wearing the mask all day, first of all, you're not going to have to worry about whether you have enough good bacteria, because you can build that up when you're not wearing the mask, and you shouldn't be wearing the mask all day, every day. Second of all, the mask is not trying to prevent little microns of the disease or the virus to get through. Obviously, we're not going to be able to stop it. Why people are wearing masks is so that if you sneeze, it doesn't get on somebody else. If you're wearing a mask, it keeps it in your face and out of theirs. And if they're wearing a mask, it doesn't get through their mask either. So we're not looking at solving the problems of the virus by just wearing a mask. What we're doing is preventing spreading of these germs as best we can with the circumstance that we're in. But if people don't do their research, if they're not curious about it, if they don't care, right, then they're just going to give you misleading information, and that's going to spread, and people are going to get completely false information about what's going on. So questions to consider, whether it's the pandemic, whether it's something else, is what do you mean and how do you know? On social media a few years ago, it's probably about 4 or 5 years ago now, there was a viral post. I know that I got it on Facebook, that McDonald's burgers don't decompose, right? And anybody that reads the headline starts freaking out. They probably repost, retweet, right? Copy and paste, whatever. But if, and even reading the article itself, it was somebody that had some sort of vendetta against McDonald's or something. They said that if you get a McDonald's burger, like a Big Mac, and you put it on your shelf in your bedroom for like 10 years, open it up in 10 years and it'll be just as pristine as it was the day you bought it, which is absolutely not true. There are two things. All food breaks down if they're exposed to two things: oxygen and moisture, right? So yes, if you sealed it potentially in a bag that did not allow air to escape or come in, or did not allow moisture to escape or come in, then even the most organic thing at Whole Foods will probably not decompose. But the point of this is that's not true about McDonald's. But people started spreading it. And the reason it went viral is because people just read the headline and got scared, and they just started presenting this misinformation. There was actually a couple weeks later an article that came out in response to this. And it was sort of a rebuttal that said exactly what I just said. But the first two lines, or the first line of the article, which I love because, of course, I open and read it all, said, "I can't believe we had to write this, but this is the truth about this." And so by asking the questions, what do you mean and how do you know? A lot of times people are quick to just repeat stuff they hear on the news or they read on the internet. And They're just repeating it because it sounds like it could be true. They're using their intuition or their common sense. What do you mean and how do you know are very powerful questions. So being curious means that you don't want to be misled and you don't want to spread misleading information to others. Thinking critically is a way to prevent this. Thinking critically, or critical thinking, is a more careful style of forming and evaluating knowledge than simply just using your intuition. We want to use the scientific method to take steps and ensure that we're doing the right things and not just guessing. But critical thinking is a way to help with that. It develops more effective and accurate ways to figure out what makes people think, feel, and act the way that they do. Here is a nice little graph of critical thinking. So the definition is analyzing rather than just simply accepting information. I could tell you about McDonald's, but I would like you to do the research for yourself. So when you're doing critical thinking, understanding the article, trying to figure out if what's true and what's not. So you want to, we'll start at the top here. Determine if flaws in the information collection exists. A lot of times people send information that is just false. One of the things I will try not to go too much into, because I don't want to make these lectures super long, is the anti-vaccination movement. The anti-vaxxer movement was based on one scientific study that was later shown to be completely falsified and thrown out. But because it's still in existence and people don't either know the story or don't care, they use that in England. It was funded by people that had an agenda, and it was based on 12 people. Now, I don't know if you know much about scientific studies, but anything less than like 200 people is iffy. 12 people did this, and they said that there was a link between vaccinations and developing autism. Later, that person said they made up the data, they fudged it, and that they apologized, and that person lost their medical license. They're not allowed to write papers, they're not allowed to practice medicine. This was a doctor that lost all credibility, and yet the paper is out there. The other thing that started the anti-vaxxer movement was that one of the women judges on The Masked Singer, who is a former Playboy Playmate, Jenny McCarthy. She had a child, and at 6 months of age or so, got a vaccine, first vaccinations, and then maybe a few weeks later, a month later, started showing signs of having deficits, autism. So naturally, based on everything, we have a saying in psychology that correlation, as we'll talk about, does not imply causation. So what does that mean? Just because two things happen around the same time does not mean that one caused the other. So in this case, she saw that the child got the vaccination, he got the vaccination, and then within a few weeks or so, started showing deficits. Well, first of all, the first time that most children are old enough to even show deficits is, you guessed it, around 6 months of age. So it's very possible, more likely, that the child had these deficits already, because a vaccination with the materials in it does not alter your genetics to cause autism. That has been shown. In fact, there was another study that came out maybe 3 or 4 years ago based on over 95,000 people that showed no link between vaccinations and autism. And I don't know about you, but the proof of 95,000 plus people, much better than a made up study based on 12 people. So it also means considering alternative explanations for facts or results. There's more than one way to get to something, right? So think about it. 2 plus 2 equals 4. Always equals 4. In math, that's where you have proof. But so does 1 plus 3. So does 0 plus 4. So does 5 minus 1. There are many different ways to get to that outcome. With the vaccinations and autism, and again, this is the last I'll say about it, but hopefully it's an interesting enough topic for you. It would be like if I were to go to the beach. Beaches just opened up again, and I were to go to the beach, or let's just say I moved to LA. I was always living in some sort of landlocked state, like, I don't know, Missouri or something like that. And so I'd never really been to a beach before, an actual beach. First time I go, I get my toes in the sand. I'm really stoked. I'm happy about this. I go into the water for the very first time, and then, ow, I get stung by a jellyfish. That sucked. It hurts. What are the odds that I get stung by a jellyfish, right? So for me, I go back and I tell everybody on social media, I call all my friends, I text all my family, all of this, and anybody who will listen, I say, don't go to the beach. If you go to the beach, you will get stung by a jellyfish. You would probably laugh your butt off at me, right? You would think I was crazy. There's no traction to that. There's no evidence for that. Yes, it happened to me, and I may have been the only person ever that it happened to. The first time they ever went to the beach, got stung by a jellyfish. But for me to say that that's going to happen for everybody, correlation, just because it happened to me, does not mean it's going to happen anywhere, right? It does not mean vaccinations cause autism. It does not mean if I go to the beach, I will get stung by a jellyfish. It's the same argument in a different setting. Searching for hidden assumptions. Decide if you agree. Looking for hidden biases, hidden politics. People will often say things based on their political belief, right? We hear a lot of different accounts of the police and Black Lives Matter and All Lives Matter and things like that. Personal connections, values, politics. People that are older that grew up this way, right? By saying that Black Lives Matter, we are not saying that they matter more than other lives. Of course, all lives matter, but all lives are not being threatened equally, right? Again, I will get off my horse there. You guys already know this stuff. And of course, discarding personal assumptions and biases, whatever your bias is, and view the actual evidence. A lot of times people will use only the studies or evidence that support their side, and they'll just kind of forget about all the stuff that says differently, right? For vaccinations, does that mean that people may die from them or get sick from them, have allergic reactions to them? Yes, people have allergic reactions to a lot of things. Bee stings, right? Pollen, whatever it is. But does that mean that, is that the proof, or is that the evidence that vaccinations cause autism? Absolutely not. Correlation does not imply causation, right? Just because A and B happen around the same time does not mean that A causes B. Skepticism. Skepticism means that you're allowed to be skeptical. You don't have to believe something just because it says it. You don't have to read a headline and think vaccinations cause autism, right? It supports questions about behavior and mental processes. Again, you ask the question, well, what do you mean and how do you know? Where is your proof, right? This is where a lot of you guys are going to hate me right now, so I apologize for this in advance for ruining your hopes and dreams. Horoscopes, a lot of times people, horoscopes are very overgeneralized statements that people can just attribute to things that they want. Relationships, money, love, whatever it is, right? And they're overly generalized so that you can fit into something. There was a man named the Amazing Randy that is pictured on the left. And the Amazing Randy is a famous magician and skeptic. He had a challenge from the 1960s until he just died a few years ago, where he asked people who said that they had psychic abilities to prove it to him. And if they could show him scientific proof that they had these abilities, he would give them $1 million, which of course was worth a lot more in 1960 than it is today. But for almost 60 years, he had that same challenge. And with that challenge, guess how many people got the $1 million? Exactly 0, because nobody could actually scientifically show that they had any sort of psychic ability. They could not prove it scientifically, and therefore nobody got the $1 million. So he has debunked and tested a variety of psychic phenomena. Again, a lot of that could be based on pattern, or it could be based on intuition or things like that. And those are not scientific evidence, right? So nobody ever won the $1 million. The last one is called humility, being humble. It involves the awareness that mistakes are possible, and there is a willingness for you to be surprised. Your guesses, even though they may be based on things that are in the real world that we see, may not be correct. One of psychology's early mottos is that the rat is always right, with testing on rats. And this may make you think of rats in a maze. So, what does that mean, that the rat is always right? This is the question that I would ask you in class. What it means is that if the rat runs the maze and finishes it, it's because the rat wanted to. If you put cheese at the end of the maze and the rat doesn't run it, it's because the rat didn't feel like running it. Maybe the rat wasn't motivated enough. Maybe the rat didn't care for cheese. Whatever the reason is, the rat is always right. It ran the maze because it wanted to, or it didn't run the maze because it didn't want to. The rat is always right. We are allowed to be wrong in our assumptions. We look at things, we test them. Sometimes they come out in our favor the way that we predicted. Sometimes they don't, and that's okay. We are allowed to be wrong. We are allowed to be surprised by what we find in our experiments. That's part of the scientific attitude. That's what we call humility. So the scientific method is the process of testing ideas about the world by setting up situations that test our ideas. And if the data don't fit, it's okay. We also don't scrap it right away. We modify our ideas, we test again. Even if we get the outcome that we're looking for, it's not enough for us to say that we've done it, we've solved the problem. We need to see if it works in other people, in other places, right? If I were to do a test of your class and I were to split you guys up, half of you would, we would do a test about studying, right? We've always heard the term that studying, or the phrase, studying helps you to do better, right? That's why we have the Carnegie unit from the syllabus and things like that. So if I were to devise a test, I would put half of you in the control group, and I would tell you guys, listen to the recorded lectures, study the notes, or look at the slides while we do it. But outside of that time, don't do anything. Outside of class time, don't study, don't look at the study guide, don't read the book, just what everybody's doing together. And the other group would be my experimental group. We'll say 6 hours a week, 10 hours a week, whatever it is. I want you to study, read notes, highlight, watch videos, whatever you need to do. My prediction is going to be that those who study are going to do better on their exam, and those who don't study are not going to do as well. So let's say we do this, right? We make careful, organized observations. The other thing we want to do, and I'll get to the whys when we get to it in the next lecture, is we want to make sure that the groups are as equal as possible, except for the variable that we're studying. So that's how we make careful, organized observations. I want you guys to do everything the same, including listening to this lecture. The only difference is outside of this lecture, don't read, don't highlight, don't look at the book. And the group that does study, I want you to do all of that. Everything else I want to be the same. So the day before the test, I want everybody to get 8 hours of sleep. The morning before the test, I want everybody to eat a bowl of oatmeal, brain food, right? We don't want people eating nothing. We don't want people eating pure sugar, donuts, right? We want everybody to have the same breakfast, the same amount of sleep, and nobody gets caffeine. That's making careful, organized observations. The only difference between groups in this study, in this hypothetical study, is the half that's in the control group does not study outside of this lecture, and the group that's in that experimental group studies, 6-8 hours a week, besides listening to this lecture. And then we analyze whether the data fit with our ideas. So here is the scientific method. You make a theory. Our theory is some sort of overarching set of principles, right? So in our example, our theory was studying helps you to do better in class. From the theory, we need a very specific hypothesis, which is an educated guess or a prediction, testable prediction that leads direction to the actual study. So from studying helps you to do better in school, we go for a specific hypothesis that we can test directly. When you so we'll use it for an exam. Those that study for an exam will get a higher score. Those that do not study will get a lower score. In this example from the book, the theory is sleep boosts memory. So it leads to a prediction. When people are sleep deprived, they remember less. When people have their normal amount of sleep, they remember more. So this leads to an experiment just like the one I predicted, right? The one I proposed before. So that experiment was about studying and not studying. Here, we can give everybody the same study material. Let's say it's 20 things to memorize. So I give you everybody, 5 minutes of class time, 10 minutes of class time, and you get to study this list of 20 items on it. And then we put you into two groups. My control group is the one that gets a normal amount of sleep. And then the next day they come back. And my experimental group gets 0 hours of sleep. I don't let anybody in that group sleep. We just pull an all-nighter and hang out and play video games or watch movies or whatever, and nobody sleeps. Then 24 hours after you learn the list, I bring you back into that classroom and I say, write down as many of those words that you can remember from yesterday's list. So the prediction is, again, you're giving study material to people before an ample night's sleep or before a shortened night's sleep. In my case, I said 0 nights sleep. When we find the answers, even if we get what we're looking for, we're not done yet. Scientists dig deeper. You get what you got, and then we say, okay, well, it worked for this class with you guys. Will that also work for people in West LA College? Will it work for people in the, in Spanish class instead of psychology class? Will it work for people in automotive? Will it work for somebody in a high school in, New Jersey? These are the things we want to know. If we can repeat it a few times and those that slept did better, remembered more, then we can say, yes, sleep boosts memory. We can be pretty sure. If it doesn't happen, we can say, well, what did we do wrong? Maybe instead of 0 hours of sleep, we give you 90 minutes of sleep, give you a power nap. Maybe that'll show more of a difference. We revise it and we do it again, right? So here's the cycle of the scientific method. Whether it's studying leads you to do better on an exam, sleep makes you remember material better, right? All of the above, maybe. So a theory is the explanation using this integrated set of principles that organizes our observations and helps to lead to predictions for behavior. Again, we can't test directly that sleep boosts memory. We can see that sleeping or not sleeping affects how many items you remember from an exam or from a list. We can't test that studying helps you to do better in school, but we can see if studying and not studying has an effect on your exam. That's our hypothesis. It's a testable prediction that's often implied by the theory. So if the theory is sleep boosts memory, the hypothesis is those that sleep will have a better memory for this list of words. Those that don't sleep will not remember as many words. And how we actually define these things, when we are making these statements, when we are doing this research and making careful observations, it also matters how we define these things. So the operational definition is a carefully worded statement of the exact procedures or operations used in a research study. And a lot of times we use very specific operational definitions because if somebody else wanted to repeat and copy our experiment, they would be able to do it exactly as we defined it and exactly as we outlined it, right? If you want to say, I brought up road rage earlier. right? If we wanted to study aggression, somebody could use the idea of how many times somebody said a cuss words, how many times they honked a horn, how many times you physically punched another person. All of those could be different measures for the same thing. So this is a carefully worded statement of exactly how you measured it. We measured studying as highlighting, reading the book, going over notes, blah, blah, blah. Just having the book open and watching TV in the other room, that's not how we define study, right? So the idea behind this is that you'd be able to use it for replication, and that is the repeating the essence of a research study, usually with different participants in different situations. So if the studying example worked, we know that it worked for you guys in this class, but did it work for another college, a high school? Did it work in Africa the same way it's going to work in the US? Did it work in South America? Did it work with elementary school students? We need to replicate it to know. If we are going to say that it's a good theory and it's universal, we should be able to replicate it at least a few times. And if it works 3 or 4 times with different people in different cities, different levels, then we can say with relative certainty that theory is pretty correct, pretty true, that studying helps us to do better, or that sleep boosts memory. Hopefully you guys are still following along. So a good theory is one that effectively organizes the information: studying, not studying, sleeping, not sleeping, caffeine, no caffeine, whatever it is. It leads to clear predictions. Those that study will score well on an exam. Those that don't study will not score as well. It often stimulates other research. Once we find that something is true, if we're able to do that, then we can say, okay, now what? Is it the number of hours studying that make a difference? Is it the type of studying? So now I can split you guys up and say, this group over here, you guys do nothing. This group, you guys just highlight. This group, you guys just read. This group, you guys use flashcards. And we can see if one of those is better than another. Or we can say, okay, we know that studying works for an exam. Does it work for a presentation? Does it work for a paper? Does it work for some other type of project, right? So either the type of studying or the type of project other than an exam, we want to see. And of course, a good theory can be replicated, right? We can see that it works in different populations with different people in different areas, maybe different levels of school, right? Things like that. So the scientific method is about testing hypotheses and refining theories. I'm going to talk about 2 of these. And then the next lecture, I will talk about the other one, which is causation and experiments. It's actually the same thing. And then after this chapter, you guys will have a homework assignment where you guys are going to hopefully come up with what are the variables for this assignment, but that'll be after the next lecture. So again, I'm going to talk about descriptive research, and correlational research. Remember, correlation does not imply causation. So, really quickly, descriptive research is a systematic, objective observation of people. In this case, the goal is to provide a clear and accurate picture of people's behaviors, thoughts, and attributes. You're just trying to describe what's happening. You're not giving a reason for why it is. You're just seeing what we can describe. Objectively observing people and seeing their behavior and things like that. So there are 3 main ways that we use description research. The first one is called a case study. And a case study is where you get a lot of information about one person. Somebody that has a rare disorder, somebody that you're just doing a study on. Maybe they have unusual quirks and you're trying to get down and collect as much information about them as possible. You may even find a lot of ideas and reasons for why they act the way they do. The one problem is, for a case study, is you're getting it based on one person. And even if other people have these same quirks or this same rare disease, that doesn't mean that they're going to act like this one person. So you can't generalize it to other people. In a naturalistic observation, a lot of times when we do experiments, we use a fake setting, and I will go into why we would do that. generally the answer is so that we can control for a lot of other factors you can't control for in the real world. But naturalistic observations, again, is a descriptive study. So we're not looking to explain why they're doing or give a reason to why they're acting the way they are. We're just trying to describe it and see what's going on. So it describes but does not explain the behavior. And the naturalistic observation is recording them in their natural habitat, in the real world. So if somebody is at school, at work, or at home and having behavioral problems, you send somebody or record them in that natural environment in order to see what's going on. Maybe you can learn what triggers them and causes them to act the way they do. Maybe there's nothing that does. This can be very revealing about a person. What they do when they think nobody's looking, or acting out to try to get attention, or for whatever reason. You're describing what they're doing when they're doing it, not necessarily why they do it. But the biggest and easiest way for people to get information, especially if it's not just one person, but a group or a lot of people, is by using a survey or interview. You're examining many cases in less depth, utilizing what we call random sampling of the population, and you have to worry about the way that things are worded. So in a survey or interview, you're asking them questions about why they like a certain product. Market research does this, why you like brand X over brand Y, Coke over Pepsi, even though personally, don't hate me for this, I like Pepsi better than Coke. There, I said it. But you can get the pulse, like who are you gonna vote for and maybe why in this next election? Why do you like Coke over Pepsi or Pepsi over Coke, right? But the way that things are worded may change people's answers. So one of the things that we worry about is asking the questions in a very simple and straightforward manner. So what that means is I can ask you a question based on marijuana legalization, and I can say, do you agree that marijuana should be legal? Very simple, very straightforward, yes or no question. But lawyers in a courtroom, when they're trying to discredit a witness, can take that same question and word it completely different. That will throw the person off, maybe make them answer it differently than they normally would have. And so what that does for, purposes of research is it screws everything up. If I were to say, do you agree that marijuana should be legalized? Or I could ask you the same question in a different way and say, don't you agree it's a terrible idea to legalize marijuana? I'm leading you in a way that makes it sound bad, horrible. It may change the answer that you have. It's asking the same question in a convoluted way. So you need to make sure that when you're asking questions on a survey or interview, that the questions are very easy to understand so that you can get the right answer from people. They're not necessarily lying, but by forming the question in a different way, it may cause them to answer differently than a straightforward question. And random sampling means that we want to get a good representation of people. If we want to know how ELAC feels about marijuana legalization, you can't just go to one area, let's say the auditorium, where people are coming out of something from the auditorium, and just hand out 500 surveys there. Because how do we know that they're not coming out of a legalization or anti-legalization rally? And then everybody's there for the same reason. You're not actually getting a representative sample of ELAC. We can't get everybody, especially now that we can't be on campus, right? So the best idea is to use random sampling. Grab a few names from each class on Canvas, or if we were on campus, to just go to each classroom and randomly pick 5 people from each classroom and give them a survey on legalization. That's a random sample. If we get a random sample, which means that everybody has an equal chance of being picked, then that's more representative of what all of ELAC has to think, as opposed to just giving out 500 surveys to some people coming out of the auditorium, right? Wow, this is interesting. So basically, this shows Twitter activity, and what this, even though I apologize for this, let me see if I can fix it at all. If I can move this down here, there we go. Perfect. So let's do that and go back to presentation. Now we can see what happened. This illustrates that without knowing anyone's identity, that we can just take big pieces of data and actually look at the activity to study human behavior and get some of these questions answered. Just like on that example I gave you about the homeless person you thought might have been homeless and crazy or diagnosable with schizophrenia or something. All you got to do is go up and ask him, and you may interrupt his thought process, but he would just be able to answer easily and tell you that he's not homeless and that he has no diagnosis, and he was just trying to remember his grocery list. So here we can look at positive words and posts, and here's the time of day, and this is the day of the week. And we're looking at trends in Twitter messages by moods. So when do you think people will be the happiest, where the lines are the highest? So here we see Saturday and Sunday, weekends over weekdays, when most people aren't working. Midnight or 11 p.m., you see it higher when they're off work. After 6 p.m., you see a big spike. Going from midnight to 6 a.m., you see a big decrease. And of course, around noon, for a lot of these, you see very low amounts of positive attitudes in posts. Noon is when you need to recharge and eat. So a lot of times people are hangry, right? Hungry and angry. Here we see, especially on Friday, Saturday, and Sunday, we see positive posts. Down here, 6 a.m. when people are waking up, I wouldn't be. And then we see even beyond noon, right here around Tuesday afternoon is when they were lowest, but you see a lot of low posts in this 2:30 time. And if you guys are, watch a lot of TV and you see commercials for like, one of the commercials I thought it was really pretty ingenious is 5-Hour Energy. I use it sometimes, and 5-Hour Energy talks about that 2:30 feeling. So noon, you have eaten lunch and maybe you have that post-lunch carb load where you're getting a little tired. You get off work somewhere around 5 or 6 p.m. so that there's that last break of the day around 2:30, and then you just have to power through the rest of work. So I thought they were geniuses by saying that 2:30 feeling, right? You're not done with work. You're halfway through the second half of your day. Maybe your energy is low because you ate a lot of carbs for lunch, had some pizza, right? So you get that 5-Hour Energy at 2:30 and it blasts you through until you're done with work, and then you have energy beyond, right? So again, from a standpoint of advertising, I thought that was pretty ingenious. But you can see that, whether or not you were right. Highest posts Saturday and Sunday, late Saturday night, on the weekends when people aren't working. And when they get off work, moods go up. When they go into work, moods go down, right? Things like that. So you can take these big pieces of data like Twitter and actually get support for your data. You can look at these descriptives and say, this goes with my theory that people are happier in the later part of the day and especially all day on the weekends. The next type of research is called correlation. And remember, I used the term correlation does not imply causation. The general definition of a correlation is some sort of observation that two things, two traits, two attributes, we can use the word variables, things that vary, are related to each other. Thus, the amount that they are correlated. When we look at it from a scientific standpoint, it is a measure of how closely two factors vary together, or how well you can predict a change in one from observing a change in the other. So, do vaccinations cause autism? Or is there a relationship between vaccinations and autism is how we say this. Remember, correlation does not imply causation. One of the probably best examples I can give is as a child is growing, there is a relationship between their height and their weight. As they grow and as their muscles develop, as their bones harden, they increase in their weight. So you see what we call a positive correlation, that as the height changes, so does the weight. So there are three, I guess 2.5 different ways of looking at correlation. There is positive correlation, which gives you a number between 0 and 1 called the correlation coefficient. And this indicates a direct relationship. If it is on the positive side, the closer it is towards the number 1, kind of like a percentage, like 0.20, 0.50, 0.66, right? 66%. That two things go in the same direction. So a positive correlation could be both things increasing or both things decreasing. So, sorry, my dog is barking at the mailman. Technical difficulties. Moxie. Okay, hopefully that'll get her to stop. It indicates a direct relationship. So if two things are both increasing, like height and weight of a child, or if two things are decreasing at the same time. So if you're trying to lose weight, the less calorie number you consume hopefully leads to less weight that you see on the scale, right? Both of those things would be a positive correlation. As one increases, the other increases, or as one decreases, the other decreases. The less calories you eat, the less you weigh on the scale. That's also a positive correlation. A negative correlation indicates an inverse relationship. So as one thing goes up, the other goes down, or vice versa. Just means that one is increasing and one is decreasing. So in this case, the higher the temperature gets, the more the temperature increases, the less amount of clothes you wear. You're not going to be wearing jackets and socks and all of these scarves and all of these things as the temperature is getting hotter. You're going to want to take off clothes, right? So there is a negative correlation between the amount of clothes you wear and the temperature. So as the temperature increases, the amount of clothes you wear decreases. As the temperature gets colder in the winter months or whatever, right? As it's getting colder, the number of scarves and jackets and gloves, boots, Uggs, I don't know, things that you wear goes up. So there is a negative correlation between the temperature and the amount of clothes that you wear. Hopefully this is making sense. So the correlation coefficient is just a number that is assigned, a calculation that we make that tells us how strong a correlation is. The closer to 1 that a positive correlation is, the better we can predict one thing from another, right? A perfectly positive correlation would be for every inch a child grows, they gain 1 pound. So if a child is 50 inches, they weigh 50 pounds. Now, of course, in the real world, it doesn't work that way. And there are a ton of other factors involved: genetics, how much food they get, the health of their diet, right? Things like that. Just like a perfect negative correlation of -1 would be every degree that it goes down, the temperature goes down, you put on 1 article of clothing for every 1 degree it goes down. You're never going to get a perfect one. I'm never cold, so I don't put more clothes on unless it gets really, really cold, which it doesn't in LA. My wife is always hot, is never hot. So she can go out in jeans in 100-degree weather and I wouldn't dare. So that correlation coefficient is a numerical measure of how closely two things vary together, or how well you can predict one from the other. So here's another one where I need to move this down, and I don't know why. In my old regular PowerPoint, this worked fine, but I'm using a Chromebook, so now these slides get a little bit lost in translation. But correlations can either be, and then there was zero correlation, which just means that they have nothing in common. That you can't predict one from another. There's nothing there. So no correlation or no relationship would be an R value. R is the correlation coefficient, lowercase r, of 0. So a perfect positive correlation, as you can see on the left, that's a +1. For every 1 unit it goes up on the x-axis, it goes up 1 unit on the y-axis, making a perfect 45-degree line sloping upward. That is a positive correlation. Child's height and weight. On the right, you see a perfect negative correlation, which is going the opposite direction. It's sloping downward, 1 unit for every 1 unit. So again, that would be like every degree the temperature goes up, you get 1 article of clothing that you take off, right? And if there is absolutely no relationship, you just get this scatter plot. This is called a scatter plot of dots all over the place. So there is no line of best fit. In fact, in this middle one where there's no relationship and it's a coefficient of 0, your line of best fit is just going to be a flat horizontal line. So showing nothing, right? Sometimes two things can look like they go together, but actually have nothing in common. And I am actually going to give you guys a link for some of these spurious correlations, where two things look like they may match because the graphs look really tight together, but they actually have nothing to do with one another. And that's called an illusory correlation or a spurious correlation. It refers to the perception of a relationship between two variables when either a minor one or actually no relationship exists. So in my research methods class, I give an example of, in the 1970s in New York City, there was one summer where the number of murders in the city was the highest it had ever been. And at the same time, the temperature was the highest in recorded history for the entire summer. So what we saw was a huge increase in that summer of temperature and a huge increase in the number of murders, which may have shown a correlation between the temperature and murders. So are we saying that the temperature is making people murder more? Maybe they're eating more ice cream and getting sugar high, and that sugar high is causing them to murder people? No, that's ridiculous, of course. There is actually no relationship between the temperature and the number of murders in the city, even though both of them increased at the same time. That is what we would call an illusory correlation. Or it may be fed by something that we call regression to the mean. And what regression to the mean is the tendency for extreme or unusual scores to eventually fall back towards their average. So let's say that I gave you that example of people studying or not studying for an exam. Let's just say that some of you guys took a Psych 1 class, maybe my Psych 1 class before, and you got through the first exam, and then for whatever reason, even though you were doing really well, you had to drop the class. You had to work, or there was family trouble, or something that was a time suck that you just couldn't get through it. So those people that already went through my class, if I put you in the no study group, you might have done really well. Or if I put you in the study group, you might have done really well, not because you actually studied, but because you took an exam that was very similar to that a year ago. And so what we would expect is for the second exam, which you didn't take, you would fall back towards whatever your average was. Before this year of 2020, I liked using Kobe as an example. May he rest in peace. But Kobe had a career 50% shooting average in basketball for the Lakers. Some days he could make 15 out of 20. Some days, especially his last year when he was coming off of some horrific injuries, he made 5 out of 20. But what we would expect is from game to game for him to go back to his average of making about 10 out of every 20 shots that he attempted. So the extreme or unusual scores, we expect that the next time they would go back to their regular average. But of course, in a correlation, you're really only measuring once. You're not measuring over an extended period of time. So that may be why you see correlations when there really are none. But no matter how strong the relationship, correlation does not prove or imply causation. Just because two things are related does not mean that one caused the other. If I go back to the example of vaccinations and autism, that's what we find. Just because two things happen around the same time does not mean one caused the other. Because there are 3 possibilities to cause and effect relationships. A could cause B, B could cause A, or something else could cause both A and B. So what do I mean? There is a definite relationship or correlation between low self-esteem and depression. Low self-esteem is a sense of, or self-esteem is a sense of self-worth. So low self-esteem could lead to depression, or it's depression that could cause your low self-esteem, or maybe some sort of distressing event or biological predisposition, having low serotonin, or your boo, your bae, whoever, calling you up and being like, hey, I would say it's not me, it's you, but it's definitely you. I don't want to be with you anymore. Peace out. That could lead to both low self-esteem and depression, right? So we don't know where this possibility is. If two things are related, we could say that low self-esteem and depression are related to each other, but we don't know if low self-esteem causes depression, depression causes low self-esteem, or if something else like your bae breaking up with you causes both. So people low in self-esteem are more likely to report depression than those high in self-esteem. And one possible explanation is a negative correlation, that bad self-image causes depressed feelings. But it could be that something else entirely causes both of those things. In a correlation, it doesn't matter. But if you're trying to give cause and effect, that's when we get to experimentation. So when we start the next half or the other portion of this chapter, we will talk about experiments, how we isolate variables, what we're looking for, and then how we look at the statistics. So this has been a mouthful. This has been a while for you. So I will talk to you very, very soon.